Hi, and thank you for taking time to watch this presentation on the Rohde & Schwarz EMI pre-compliance debug solution. Moving a design from silicon to silicon carbide offers the potential for higher performance and efficiency while reducing cost and size. The initial hurdles for silicon carbide were reliability concerns and price sensitivity. While these issues have had significant resolution, SiC may still not be a drop-in replacement. Implementation includes a learning curve for optimizing the design and addressing packaging issues. Now, noise is raised to the surface as a potential limitation. Fortunately, silicon carbide vendors offer numerous design tools and a wealth of literature to make migration to silicon carbide less painful. Rohde & Schwarz also offers a breadth of tools for testing EMI early in the design process to ensure a SiC design will meet stringent EMC requirements. Generally speaking, design guidelines which have been used for IGBT modules apply to silicon carbide, but at significantly faster switching speeds. These high switching rates require more careful attention to understanding the effect of parasitic elements. When you consider critical areas of EMI susceptibility early in the design process, you have to evaluate all loops and connections. For power electronics, and especially SiC, area of concerns are parasitic inductance around the power device and load, inductance at the gate, coupling between the gate drive and the power device, and between the traces in the substrate and base plate. In the past, oscilloscopes were not commonly associated with EMI testing due to performance, FFT, and analysis limitations. However, that changed in 2010 when Rohde & Schwarz introduced the RTO oscilloscope series with a number of innovative features and enhancements. Along with the scope, EMI pre-compliance testing requires a line impedance stabilization network, or LISN, which acts as a low-pass filter, preventing high-frequency noise from coupling into the system from the source. Leveraging the power of the scope and using an accompanying LISN, R&S has introduced software which offers users a time-saving method for conducting EMI pre-compliance testing. While not intended to be a replacement for full EMC testing, this testing solution uses the FFT trace feature of the oscilloscope to make frequency scans and trigger masks are used as limit lines. Given the powerful FFT capability of R&S oscilloscopes and this software analysis tool, users can quickly obtain results that are comparable to using a spectrum analyzer. Recently, Wolfspeed and Rohde & Schwarz collaborated to determine if replacing silicon MOSFETs with off-the-shelf silicon carbide MOSFETs would demonstrate an increase in system noise. Wolfspeed made these measurements using an RTO 2K series oscilloscope and the EMI debug tool for oscilloscope software. Prior to testing the silicon carbide MOSFETs, a baseline was established on a reference unit with silicon MOSFETs that previously passed EMC certification. Using the EMI debug tool for oscilloscope software, the test results show that the results were well below limits. Replacing the silicon MOSFETs with silicon carbide MOSFETs is TO247-3, and utilizing sound mitigation techniques, the testing was repeated. The results once again show that they are well below required limits. This is an excellent indicator that the design is ready for EMC compliance testing. Later, the design was run through comprehensive EMC testing, and the results were similar to what was discovered using an R&S oscilloscope and the debugging software. Some of the advantages of using the EMI debug tool from Rohde & Schwarz include: you can configure up to 2 FFT traces, you have selectable limit lines, you can use predefined CISPR setups, or you can actually create custom limit lines. You have transducer support, report generation, and screen capture saving capability. Thank you for watching this presentation on using the Rohde & Schwarz EMI pre-compliance debug tool. If you have any questions, please contact one of the exhibitors.